Hi. Can you hear me, guys?
I can hear you.
Yes, yes.
Okay, great. So we'll continue with my with SQL, like the second part of DML, data manipulation language. Let's just wait a little bit because people are still joining the meeting. Okay. Can I share screen with you?
Not yet.
Yes, sir.
Right? Okay. Very good.
Yes, we can see the screen.
Very good. Very good. Okay. Admit. Oh. Okay. So last time we talked about renaming attributes and relations, and then joining and then sorting. Today we're going to talk about grouping and aggregation. But before we do that, I'll remind you of what SQL. So I hope you hold it right. So this is because I'm using Mac, right? So this is the client, right, that I'm using for my SQL. And then I click on website. And that takes me to this link. Okay. Right. This is the database we're looking at. My database SQL. It has father, child. It has some rows or records in there. I have the table mother, child, right, which contains few records. Who she's the mother of. And I have, which is the table that contains the information about every person and income, right? So if we look at the table, the name Andy, he, okay? Right. So back to the slide that we were playing with. Right? I have the three tables and I have two foreign keys per table, person, so one from father and one from child, and the same thing for mother, child. I have from foreign key to name of person and child also name of person. Okay. Okay. Sorry, I'm still admitting people, so I'm a little bit interrupted. Hopefully this will stop in a second. Okay, this is the database instance. So some the three tables. So we have the person with some records of the child. So it tells you Lisa is the mom of Mary, Lisa is the mom, and Steve is the father of Frank, and Greg is the father of Kim and Phil. We looked at was renaming attributes. So how do I rename attributes? I use the as operation or keyword. So here I'm saying select name as person name, income as salary from person. What I should see is I should see the table, these two attributes projected as person name and salary. Let's try this query out. So let's say I say select. Can I copy it? Tab, and then box, and I execute. Okay, if you look at the records, right, projected on these two columns, and set other than age and income. Yeah, so this is because of the as keyword. Please feel free to interrupt me or ask questions if you have any. Again, right, make sure you install MySQL. Try things out. The script for the data inside of it. So you can actually try all of these queries. Okay. Joining relations, and we said there are two ways of joining. Like from two relations or more, and then put the join condition in the join. Yes. For all people who earn over 30K. So there is a condition on the income that it's greater than where the child is equal to me, because I want the income of the child, not the income of the dad. Okay, if I try this query, we're not going to try every query that we did last time, but just go. Here's the results. You scroll down. Is the only person who's a father of someone who makes an income from the slide. Any questions? Where's the chat? The chat thing. I like Zoom more, but this has the advantage of
Chat button is below, I think.
below. Okay. Yeah, I see it now. Zoom is better, right?
Zoom is better, by the way.
Yeah, it seems better, but there is a limit of 40 minutes. So we're gonna go back to Zoom most likely next time. But then and then start again. The same link. So let's go back to Zoom the next time. Okay. Okay. Doing joining, which is we do it using the keyword drop attributes that projected from the two tables R1 and R2 on the condition C, right? So selection as well. So you do a selection people more than their father, showing their names and the incomes of their fathers. I need to join the table person with father child twice. Yeah. To get the income of the parent, one to get the income of the child, and then have a condition that the child the income is greater than F. Right, let's try this query out. I'm going to copy. And consider. And as you see, Kim, whose income is right 40. Right, so basically that his child makes more 21, and the dad makes 40. Also, Andy makes 21, and the dad, right, his dad makes. Okay. Let me see. Are there anybody waiting? Okay. Put natural join, left outer join, so we can do natural join. Left outer join. So here I'm trying tables father child, and I want to join father child left after join with mom. So I get all the fathers and their mothers, and the mothers, if there are. Let's try this query out. Go here. Fine. Box. Get also that child. Right. So father, child. So basically select father, child, or child. So the name of the child, the name of the father, the name of the mother, right? If it is known. Yeah, so I should expect to see some nulls in that column. I get Frank, Steve, the mom is unknown. Anne, for Phil, Greg, the mom is Anne. For Anne, the dad is Frank, the mom is Mary. And for Rob, the dad is Frank and the mom is Mary. Kim and Phil are siblings, and Frank has good. Let me see. Do we have anybody waiting? Okay. One quick remark, right? In my there is that's some. So basically, it right. If you have questions, either by chat or just ask me questions. So again, right. Right outer join, you have not join, but you don't have full outer join. Yeah, so you have to do it using something else. We'll see how to deal with this later. Okay. Okay. About sorting, so we're going to example of sort. So here I have, like, for instance, right? Select only those who have. So I will order the records, the resulting records. Yeah, so I can try this query out. Even with selection here, we can say, okay, just order people based on names from table person. To go, I get to see, right, sorted ascendingly based on Andy, then Anne, then Frank, then Greg, and so on. Okay, can sort them based on age. This. When I sort based on age descendingly, I should get them sorted. Right, so I get Mike first because that's the oldest, followed by Steve, Lisa, and so on. Okay. Now let's do something new. So we're going to do aggregation and grouping. Remember aggregation and grouping in relational algebra? So we had 5 built-in aggregation functions in SQL, similar to relational algebra. Count, which counts records, minimum value over a range of values, maximum, which computes the maximum. Okay. So we usually use these aggregations with grouping. Yeah? So we do grouping and aggregation. So I select a set of attributes, a set of aggregations. So select A1 to AN, set of aggregations from a given table or multiple tables joined to area, and then I group by these selected attributes. So the important thing to notice in grouping is that these attributes, other than aggregations, are the ones that I group with by them, right? So only that I group by them, right? Nothing else. We'll understand why in a bit. Let's see an example, just without grouping. Just count of asterisk from father child, where father is equal to Frank. Who can tell me what? Any thoughts? I say select count of asterisk from father.
Does it count the number of children?
Yes, of Frank, right? So it selects, right? Basically, the number of children of Frank. So the where clause gets me the record only. And then I select the count of these records. That tells me the children of Frank, yeah? If I do this query on this table, right, I get that, right, I have Frank has 2 children, Andy and Rob, so I get, let's try it out. Like count of asterisk from father child, where father is equal to Frank. And I expect to see the answer is 2, right? So this is what it shows you. It shows you, right, which has only a single cell, right, which has the value 2. Okay. Good. Right. Select, right, so selection, so the where part, and then do aggregation, right, based on count. Father or count star, count the number of records. So here we're saying select average income, or let's say I want to find the average income of Frank's children. First of all, I need to join the table father, child with person to get, right? I have, right, select whatever from father, child, comma, person. What is the join condition? The child of the child, right? Basically, that it is the child information. So I say, right, child is equal to name. Filter these guys, so select only father is equal to Frank. So we get only the records that are related to Frank, right? So children of Frank, and then simply just get me the average income from father, child, comma, person, or father equal to Frank, child is equal to name. Right? So I have here, join this table with name. So only for Steve Frank, I get, right, 60 and 20. For Greg Kim, 41, and so on. That's the first step. And then I filter so that father is to Frank, Andy, and then Andy has Frank, Rob, 25, 15. These are. Now, what do? I do average income of, right, so column income of these two records. So I have 21 plus 15, that's 36, divided by 2, because there are 2 records. That's verified in MySQL. I'm going to run DD. Okay, written DD box. Select, right. I have to just that it's a string. So select average income from father, child, comma, person, where father is equal to Frank and child is equal to name. And as you see, I get 18. Average income is 18. Any questions so far? Any questions? Okay, guys. So about values. That's a question that a lot of people ask about, right? So what happens when I have null values and I'm doing aggregations? We never talked about this in algebra. So here I have the table person, and let's assume I have just these 4 records. And income for Rob is unknown, so I set it to null value. Yeah. So income is not part of a primary key, so I can set it to null values. Okay. So now I say select count of asterisk from person, income from person, and select count of distinct income from person. We want to see the difference between these 3 ways. So the first one, select count of asterisk from person. What is the result? Count of star. What do I get? Yes, 4. Why? Because I have 4 records. So count of star means count all the records inside the table. So I get 4. Exactly. Oops. Okay. Now let's see the second one. Select count of income from person. Count of income. Now I'm looking at this column, right? And I want to count the values inside this column. What happens? I have null values or not? The answer is you don't, right? You get 3. Whatever is not null, exactly. So you get the value 3, right? So everything, when you look at count, or it ignores. Okay. So now select count of distinct income from person. What happens when I do select count of distinct income from person? I get 2 exactly. The answer is 2. Right? 21 is repeated twice. So I'm looking at distinct values. Okay. Questions? Okay. So null values are not counted in the count aggregation. Let's see if I do average. So other from person. So I want to do average of the income of that all the people inside the person. Okay. What do I get? Got 36 plus 36 plus 30 divided by 3 or divided by 4? No, by 3. Again, right, exactly. 36 plus 3 plus 36 plus 30 divided by 3. Exactly, right? Because null values are ignored. So null values are ignored in any aggregation. Why? Because we don't know it. So if I have multiple null values, these guys will be ignored. I'll only select the values that are and average over them. Only the values. Okay, so I get 34, 36 plus 36 plus 30 divided by 3 is 34. So null values are ignored during aggregation. Now we're going to go to the difficult part, which is the grouping. So we have aggregation in the previous aggregation without any grouping. Yeah. In this part, we'll look at aggregation and grouping. That's really a type of query. Difficult in the sense, right, that people get confused a lot about it. It's a very important type of queries. This is really what most of your applications will do. We do aggregation and grouping because you want to provide statistics, right, about your database. Okay. So we can also group on a set of attributes and apply the aggregation on each group, like we did in relational algebra. Yeah. However, the projected attributes must be either one of the group by attributes or an aggregation. So I cannot only grouping by it, or it's an aggregation of another attribute. Let's see an example. So let's say I want to find for each group of adult people meaning greater than 18, their age is greater than 18. Is based on age. So get me for every group of people that have the same age, their age, their maximum income. So let's say I have 3 people who happen to be have the age 21, right? Then I want to show 21. That's and the maximum income out of these 3 people that have age 21. Okay. So here's how I'm gonna write. Maximum of income, so aggregation over the income column from the table person, because the table person contains this information. The where clause here just selects the people who have age greater than 18. So I'm doing first a selection on top of it. Yeah. So group by. So basically, first thing to do is to get me all the people who have age greater than 18. These are the records that you're going to be selecting. Then from these, group by age. That's the second step, is to group them by age. So basically get all the records that have the same value of age into a group. And then per group, output the age and the maximum of age. This query on the table that we have. Okay. So first of all, selection. What happens? Which records are selected? Only those guys age greater than 18. Yeah. So basically, Andy will qualify. Rob will not qualify. Rob will qualify. It turns out that all of them qualify. All of them have age greater than. Okay. So I have all of them have age greater than 18. So all of them would qualify. What we need to do is group based on age. So Andy, 27 and 21. Do we have any other record which have the same age? Yes, I have Kim 21. So that's one group, right? I have two records with the value for age equal to 27. That becomes one group, right? And what is the maximum income in that case? For the age group 27, it's 41. Yeah, so I get the record 27 and 27 and 41. So that's the first record here. Second thing, Rob 75, 15. Is there anybody with age 75? Yes, I have Mike and I have Lisa. These all one group. So this guy, oops. Rob 75 and 15. Mike 75 and 35, and Lisa 75 and 87. All one group. What is the maximum income for this group? Rob 15, Mike 35, and Lisa 87. Right? That's the maximum. And so on. Yes, 87. Okay. For instance, 55, I have only one record with the value 55 for age. So I get this as just one, like another group. The maximum income in that case is the income of the only record, that's 42. And so on. So 50, I have two records here which have 50. I get one record corresponding to them, and the maximum income is 40. Okay? Questions? Okay. So this is equivalent to what? Algebra. We did this in relational algebra. We do select such that the age is greater than 18 from okay? And then you project on the attribute age and aggregate and get the maximum. Okay. Let's see this query. To find fathers with their incomes, I find fathers and their incomes. What do I need to do? Right? Because the income is in another table. I have father and the child, and the income information is another table. Right? To get the income of the fathers, then I should join such that name is equal. Yeah. So that's the first thing that that we need to do. Father with person. There is a group by in relational algebra. Edmund, there is, right? This is how it looks like. It's an extended operation. It's not in the original relational algebra or the basic relational algebra. It's an extended. Use the simple delta for it. Okay. So now back to the example we have. So we want to find the father's incomes. So I need to do join between father, child, and person, such that father is equal to. That will give me the incomes of the father. And then the average income of their children. So I need to get the income of the children, okay? So such that child is equal to name. That will give me the income of the children. And then once I have this, I group fathers, the name of the father and the income of the father and income of the children. So the query. Select f.name, f.income, c.income. What is f? It's a copy of person, right? What is c? It's a copy of person. And join, these two tables are joined with father, child. First of all, the first join is f.name is equal fc.father. So join the person f with father, child based on the fact that father get the income of the father. Second join is based on child is equal to name. So fc.child is equal to c.name. So then person c, the income would represent the information about the children. Great. So I got all the information. Basically, all the fathers, their children, the income of the child, the income of the father. Now I need to do some grouping. Yes, for every father, right? you get the average income of his child, of his children. Yeah. So I group by f.name, income, average, and then project f.name, f.income, and average. Question for you, right? Why do I need to show and to the f.name, comma, f.income? If I want to project the name of the father and the income of the father, then I have to group by both of these attributes. Even though, right, it's sufficient to just group father name, right? That will give me the grouping I need, but I cannot project then the f.income. Yeah? So if I try to project the f.income without having grouped by the father name and income, then it will give me an error. Okay, let's try this query out in SQL. Please ask me questions if you have. Okay, I'll scroll up. Is the query. Okay, so I'm selecting f.name, f.income, and average income of the child from person F, father child FC, person C, where the join condition, and then grouping by f.name and f.income. Okay, and then I say go, and what do I get? I get the following. Right, the name is Frank. His income is 20. The average income of his children is 80. Greg. Now, can you see the MySQL? There's a bit of lag, it seems. Can you see now the MySQL? Okay, there's a bit of lag. Sorry for. Okay. Here's what I have, the query, right? I just copied and pasted the query, and here's the results. Frank, 20, right? His children, the average income is 18. Greg, the income of Greg is 40. His father's income is 35. And Steve, his income is 23, and the average income of his children is 20. Okay, back to the slides. Okay, let's try this query out manually now. Yeah, so let's try to do this query manually. Can you see the slides? Okay. Yes, I'm joining this table once with person based on father equal to name. Father is equal to name. Okay, so that would give me Frank, Andy, Steve, Frank, and then Steve, 23. Okay, so get me the income of the dad. Kim, and then Greg, 50 and 40, and so on, right? So this grabs income of the father. Now I do the same, right? Once with another copy of person such that child is equal to name. Steve, Frank, and right, Frank 60, 20. Yeah? So basically I get the following. Steve, Frank, right? The income of Frank is the income of Steve is 23, and the income of Frank is 20. Right? Plus their ages. Okay? So that would be one record in after the join. I'm doing group by f.name and f.income. So for every Steve, right? There's only one record which has the father Steve. Then it will be Steve, Frank, right? Frank 60 and 20. So basically, I get the average income for Steve, right? Steve has only one child, yeah, which happens to be Frank. Okay. For Greg and Phil, so I'll get Greg, his income, which is 50. Sorry, Greg, what is his income? 40, right? So I get 40. Kim and Phil. So Kim and Phil. Phil makes 30. Kim makes the average summation of these two divided by 2, I get 35.5. Okay. And then I get for Frank. Frank has 2 children, Andy and Rob. His income is 20. His income is 20. And then the average income of his children, Andy and Rob. So Andy makes 21, Rob makes 36, divided by 2, I get 80. Okay? This is the results when we run the query on MySQL. Just remember again, right, if I want to project the names of the attributes, f.name group by f.name from f.income. This is in the standard SQL, right? MySQL might work without grouping by f.income if the f.name would give you unique groups, but the principled way is to do it this way. Yeah. So everything that you're projecting here, you write. Questions? Okay. You can come up with the relation for this. You would have to do some joins, 2 joins, and then you do right where you have the grouping is f.name and f.income, and the aggregation is average child.income. Yeah, so you can come up with the questions so far. Okay, so I want you to do the following. To go to Moodle later on, right? Not now. You see Moodle? Okay. In Moodle, you have the following. You have so WAMP server installation instructions. So basically, how do I install instructions there? So you can download it and install it on your MySQL. Yeah, so follow the. You have the script here, create parents in the slide. Yeah, so please try to run the script once you have installed MySQL. This will give you the database that we're working on, and then when you review, repeat these queries, right? So try to write these queries on MySQL without looking at the slides and see the answer, the correct answer. So now, we haven't talked about so listen carefully. I can do the following, right? So once, yes, there's a version for Mac. This is the one I'm using. So just type Mac, and it should. Okay. So now let's see the following. We have a select. This is the general form of a. I select a set of attributes and a set of aggregations from a point. I can have a where condition, which filters a little bit of the records from the table before I do grouping. Right? I filter from the table, so select rows from the table, then do the grouping based on these attributes. On the groups. Yeah. Now I can do the following. I can do post filter after the grouping by using the having keyword. It means the following. It means we have this, right? So we have this query. It's the same as before, right? So I'm selecting the father's income and the average income of the children. Three tables, right? Joined once for father and once for the child. And then I'm grouping by the name of the father and his, right? So we did this query just a few slides ago. This is the query we ran. And this is Frank, Greg, and Steve. Their income is 20, 40, and 23. So the three fathers that I have in the table, right? And the average income of their children. Okay. The following, I can say, only give me groups which satisfy a certain condition. Having C income than 25. What does this mean? Okay, so yeah, there is a bit of a lag. I hope we're still on the same, still following. Okay. Yes, I can repeat my SQL. So let's see. The query, right? So we're looking at select the, let me zoom in. The father's name, the father's income, and average income of his children, right? From few tables joined together, we've talked and his income. If I execute this, I get three groups because I have three different fathers. With two children, right? 20, and I have Greg, he has two children as well. His income is 40. And then one child, 23, and the other one. I do having, right, comes the grouping. After I've done grouping and aggregation and every average of income. See this income because greater than 25. If I do this and execute, I get only 40, and his average, the average income of his children is 35.5. Right? The rest disappear. The rest of the groups disappear because the children is less than 24. Is this clear now? Okay. Can you the SQL statement to find fathers whose children under the age of 30 have an average income greater than 20. Okay. So we need to think about it, right? I want to find fathers with children under the age of 30. So where does this come, right? Age of 30, right? Age under 30. Where does it come? Yeah. Is it in the where clause? Is it in the having? It's a condition. And then, right, having an average income, right? Father. That's really what I want from What is DML? Right? I have a join. I want the age of equally in that case, right? So that person is a copy of the child, right? So this way I get right the children. Okay. For child and age is less than. So the children who have age less than 30, and then for every father. So if a father has children and one of them is greater than 30, his age is greater than. Okay, so I'm grouping by father. Now for every father, I get his children, right? That are less than 30. Okay, group by father. Having average. Okay. Right. So I know the income is for the children, so having average. Okay. Let's execute this query. Only Greg, right? So Greg is the only father who has right. Greater than 20. Yeah. So here just with aliases, right? So select, of course, the average income of the child. That's fine. So I can verify it's going to be greater than 20 from father child FC, person C, aliasing. We don't need it because there is no ambiguity. I'm joining such that child is equal to name and the age is less than 30 by father, and then having the average income greater than 20. We can combine where conditions with having, right? And you have to know which condition comes in the having clause, which condition comes in the where, and so on. So far, so good. Is it clear? Any questions? Okay. So summary of the select statement. You have a select, right? That's a very general form of a select. You have select a list of attributes, aggregations. So list of attributes could be just coming from tables. Expressions could be a column times 0.05 or a column plus another column. So that's allowed. So these are expressions that involves multiple columns, and aggregations like count, max, min, average, and you can have multiple of them at the same time. From a list of tables, right? So table 1, comma table 2, comma table 3, where you have some selection and some join conditions. You have a group by, so the group by comes next. Having comes next, so you can filter these groups, right, based on some condition on the aggregations, typically, and then you can finally order the results based on a particular order. So the last thing that happens is the sorting. Yeah. So first select from the tables, joins. You can then group by after you do the selection and join, filter by having, and then finally sort the results. So mainly we've covered almost everything from basic SQL. So we're gonna talk next, right, about what is called nested SQL, but that's the topic for Thursday. I'll just add one more thing and then we're done. So here's a good place to take some questions. Yeah, Ben. Okay, before the WebEx, is it slow? Is it lagging? Can you give me some feedback? You can turn your mics on or write in. I need some feedback. Lag.
It was lagging here, but I don't know if the problem is on my end.
Okay, so Zoom is better, right?
But Zoom was better, yes.
Stick to Zoom. Lagging plus slow. Okay, so you see some people saying lagging plus slow. So let's stick to Zoom. And some people were in 4G and still lagging. Okay. Okay, good. So we'll stick to Zoom and hopefully, right, will not. The issue is what? I guess the same issue that we have some internet issues, and for me, both are the same. Okay. So yeah, we also have it's Lebanon, right? So we have definitely we have internet issues. So I'll try to be in a place where the internet connection is fast. Hopefully you managed to get something out of the lecture. The lecture is recorded, so I'm going to post it on Moodle, and you can really revisit all of this. Something else we'll do. Just the last thing we're going to do is set operations today. Yeah. So remember set operations in relational algebra, union, intersect, set difference, and so on. So again, we're going to play with the same schema. So I have the table father, child, mother, and person. And right, these are the instances of the instance of the database. It has some records, the same records. And we're going to perform set operations between two relations, yeah, two or more select statements. So basically, select statement, another select statement, and do some set operations between them, like section and set difference. Okay. Again, as we discussed in relational algebra, whenever I'm doing set operations, the two right select statements must have the same schema. Yeah, meaning what? They must have the same number of projected attributes, data types or domains. Yeah, not necessarily the same name. We could have different names, but they put the same number of attributes and the same number data type. Yeah. So basically, I can't have father the table person because they have different schemes, or I can have father child because they have the same schema. Yeah, we have both two attributes and both of them are strings or variables. Okay. There are four set operation, basic set operation or main set operations in SQL. There are ones, right, like division, but it's not implemented everywhere. Okay, so what are the four set operations? We have union, all. This takes two select statements and combine the results of these two statements. Combine the result of two statements eliminating duplicates. Remember that union, remember multi-sets. In SQL, everything is a multi-set. Yeah, so the duplicates are not eliminated by default. You have to eliminate them